Alright, so if a ball falls for 5 seconds, if an object falls for 5 seconds, the idea is, how far would it go? Alright, that's what I'm trying to figure out. And the velocities would be looking like this, right? The object would be speeding up as it falls downward. So your beginning velocity, let's say you drop it from rest, so your beginning velocity would be 0, right? So your initial velocity is 0, that's your beginning velocity, and then your velocity vectors just get longer and longer. Your acceleration would be down the whole time, and it would not be changing length, right? So these would be like your acceleration. As time goes on, your acceleration doesn't even change, all right? And let's make down positive, since our velocities and accelerations are both down. That makes the problem a little bit easier. So I'm going to sketch some graphs now. Position, velocity, and acceleration. Okay? And what I'll see, hi there, give me just a sec. What I see is, if down is positive, my acceleration's got to be positive. If down is positive, my velocity looks like it starts at 0, and then my velocity changes at the same rate the entire time. So I have a straight line. And then my position graph should be this nice, beautiful curve showing the object speeding up in the positive direction. Okay, and we wanted to know, let's see, how far the object's going to fall in 5 seconds. Well, I can just take this displacement here, right? And I know my time I'm talking about is 5 seconds, so I'll label 5 seconds on all my graphs. And I'll label my acceleration to be 10. I'll put units on my graphs. And you're good, home chicken. And then, yeah, I'm just putting units. And then what I could do is I could just look at my acceleration graph, and I could find my change in velocity, right? And I just multiply base times height, right? 10 meters per second squared times 5 seconds. And what you should see is that the seconds cancel, and then what I'm left with is a change in velocity of 50 meters per second. So if I start with 0 velocity from rest, my ending velocity at 5 seconds should be 50 meters per second, right? And now that I know my final velocity, right, the other way I could have found that is I could have used the equation of that graph, right? I could have used final velocity equals beginning velocity plus the change in velocity, which is acceleration times time, right? So again, your final velocity is your initial velocity plus the change in your velocity. That sort of makes sense logically. So your final velocity is like your beginning velocity 0 plus acceleration 10 meters per second squared times time, which in this case is 5 seconds. You notice this gets me exactly the same thing for my final velocity at 5 seconds, right? So that's how I get 50 there. So now I want to take the area of my velocity graph will give me my change in position, right? So that's a triangle. So it's going to be 50 meters per second. It's 50 times 5 seconds. And of course I have to divide by 2 because that's a triangle, right? So that's 25 times 5, which should be 125 meters. And that should be how far an object falls in free fall. It should be the same as my displacement, because my object didn't change direction or anything fancy. It just went started from 0 position, and it must have gone 125 meters in that 5 second time period. I hope that helps. Have a good day.